Hello viewers, in this video lecture we are going to discuss the nitration of benzene. This reaction is based on aromatic electrophilic substitution reaction. We already discussed the general reaction mechanism, how the electrophile will substitute on the benzene. The reaction takes place in two steps. First, the pi electron of the benzene attacks the electrophile and forms rhenium ion, and this rhenium ion will get stabilized by losing the hydrogen. That hydrogen gives its electron and gain back its aromaticity. So this reaction takes place in two steps. So I given that video lecture link in the description. Please go through that. Now we are going to see various types of aromatic electrophilic substitution reaction. In that series, first we see how the nitration takes place. So this is the overall reaction. Benzene react with nitric acid in the presence of sulfuric acid gives nitrobenzene plus this one water. Okay, so this is the overall reaction. Now how the reaction mechanism takes place, that we will discuss one by one. So this is the first step, is formation of nitronium ion, that is electrophile formation. So now how the electrophile will form from the nitric acid and the sulfuric acid. Now both are acids. How the two acids will react each other? Listen carefully. You could have learned about amphoteric. Here the nitric acid is amphoteric in nature. That means here it can act as a base, and this is going to act as an acid, that is sulfuric acid. So this nitric acid is going to take a proton or abstract a proton from the sulfuric acid. So finally it forms like this. The oxygen will get here positive charge. Like this it formed. Now this H2O will be a good leaving group here, and it forms minus H2O and gives like this. Now you see here the nitrogen is not having the octet. That means the oxygen can donate its lone pair electron and form a octet like this. Now this will be most stable, like this. Okay, now the electrophile has been generated. Okay, nitronium ion. This is a full-fledged electrophile. Now the benzene can react with nitronium ion like this. So you will get this intermediate. So this carbon will get positive charge. So you have to be careful, and when you are rotating the electrons and the charges, that you have to do it very carefully. Okay. Now you see the benzene lost its aromaticity. It's not having the sextet. Now it can undergo various resonance structures that we no need to discuss now. Now I am going to write directly out the second step. So this is the first step. Okay. The attack of the electrophile by the benzene ring. In the second step, loss of hydrogen by that donating, the hydrogen donates its electron towards the benzene like this here. So the sulfate ion will abstract this hydrogen and it go as a H2SO4, and finally you will get like this. So this is nitrobenzene. Okay. So this is the overall reaction mechanism. Okay. The first step is generation of electrophile from the nitric acid, that is the reaction between nitric acid and sulfuric acid. The nitronium ion is generated, that is an electrophile. It is attacked by the benzene. That takes place in two steps. And first step is, this is arenium ion, intermediate. You can write various resonance structures. That is not important too much here. And the second step is regaining the aromaticity, restore of aromaticity by losing the proton. Okay. So this is the overall reaction mechanism in the nitration of benzene. Okay. See you.